Mr. Abbott here, and time for another boring activity explanation. This time we're going to be looking at a part of the Geologic History lab. In this activity, we are interpreting 4 geologic cross-sections of different rocks exposed at an outcrop. We're going to be looking at Outcrop C and Outcrop D. Now, when you look at a sequence of rocks like that, usually you start numbering them up from the bottom. You'll see that we have 3 separate sandstone layers, number 3, number 7, and number 8. Those layers, even though they have the same rock type, definitely have different geologic ages. They probably have different index fossils in them. Between 7 and 8, you see an unconformity, which represents a buried erosional surface. Okay, so even though 7 and 8 are the same rock type, they could be hundreds of millions of years apart in geologic age with completely different fossils. They probably represent similar depositional environments, but you have similar environments happening throughout geologic history. So you can't just look at rock type, you also have to look at index fossils and locations. Now, within this sample, you see in this outcrop, you see a few other things. Definitely at the bottom, you see an indication of some type of crustal movement that happens to be folding, definitely caused by compression, probably at a convergent boundary. You also have an igneous rock. This is granite. You'll notice that there is contact metamorphism all along the bottom. Clearly, 10 is younger than all of the other exposed rock layers because it cuts through them. It also metamorphoses them. One thing you should realize is granite is intrusive, and the fact that there's no contact metamorphism on the top indicates that probably the last step in this outcrop was extensive erosion. Granite forms deep below the surface, so to find granite at the surface means that you must have had lots of erosion to expose that granite. So we're looking at this section. We're going to lump groups of rocks together. So at the beginning, you had to deposit the sedimentary rocks at the bottom, layers 1 through 7. So we can say deposition of sedimentary rocks number 1 through number 7. When those rocks were deposited, they were horizontal. Obviously, there was a significant, crustal movement. You had some type of plate boundary, probably a plate collision, which led to the folding of 1 through 7. Once those rocks were folded, that led to crustal uplift. If you uplift rocks above sea level, they're exposed to weathering and erosion. Okay, so the next step would have been the formation of Unconformity Z. All right, so looking at the outcrop diagram, 1 through 7 were deposited horizontally. Okay, there was a plate collision that caused uplift and led to the creation of this erosional surface. Okay, for it to become an unconformity, which is a buried erosional surface, the entire area had to subside or sink back down, and then more deposition had to occur on top. So after your unconformity, you had deposition of layers 8 and 9, but you also know there must have been younger rocks. Since 10 is intrusive, it had to have rocks on top of it so it could cool slowly deep below the surface. Okay, so our last couple of steps here, we have deposition of sedimentary rocks 8, 9, and younger layers. those younger layers have been removed by erosion, but honestly, they had to be there for the granite to be intrusive. So step 5 is intrusion of granite number 10, followed by uplift and erosion. Usually you'll see granite exposed at the surface in areas where there is, old mountain ranges that have been eroded for a long time. Now, our last outcrop here is Outcrop D, rather a famous location. This is going to be looking at the Grand Canyon sequence. There are 18 rock layers exposed, at least in this section of the Grand Canyon, and honestly, we can do this in 10 steps or 10 events. So you're looking down at the Grand Canyon sequence. We've numbered it from 1 up to 18. Your diagram may not have it, but there's definitely evidence of 3 unconformities. You've got an unconformity that I labeled X between the schist and these sedimentary rock layers. You'll notice that this unconformity has been tilted. Y is above the tilted sedimentary rock layers, and a little bit of it is between the schist and sandstone number 7. Okay, finally, you have a third unconformity here, which I'm labeling Z, which is going in between layers 9 and 10. So, first question is, what's the relative age of the schist and the granite? The granite cuts through the schist. The granite also metamorphoses the schist. So the oldest rock layer here had to be the schist, followed by the granite intruding it. Honestly, the schist had to have been something else. That's a metamorphic rock, but we're not going to go into, there was a rock before the schist. So we're starting off here for number 1. We're going to do formation of schist number 2, followed by intrusion of granite number 1. I believe it's the Vishnu schist and the Zoroaster granite, but I may not have that perfect. Above those, you have an unconformity. So we can go with unconformity X formed. Okay. Then we have deposition of sedimentary rocks. Okay, I guess it was number 3 through number 6. When you're looking at outcrop diagrams, you have to remember the idea of original horizontality. When you look at this sequence of sedimentary rocks, they're currently tilted, but when they originally formed, those must have been horizontal. So the fact that these layers appear tilted means that there was some significant tectonic event, some massive crustal movement, that led to the unconformity above it. You'll see the unconformity below it is tilted, which means you're not tilting layers 3 through 6. We actually have to have tilting of layers 1 through 6. When there's a major crustal movement, all of the existing rock layers are affected. So after 3 through 6 are deposited, you would have tilting of number 1 through number 6, followed by the formation of unconformity Y. Above Y, there are more sedimentary rock layers. So when we look above Y, you'll see sandwiched in between unconformity Y and unconformity Z, you have sedimentary rock layers 7, 8, and 9. All right, so for here, we'll do deposition of 7 through 9, followed by, for the next step, we'll do formation of Unconformity Z. Above Z, we have a whole sequence of deposition. 10 through 18 were deposited. Okay, the change in the rock type probably indicates a change in the environment where the deposition was occurring, maybe a riser full of sea level, but you'll see you have a whole sequence of continuous sedimentary rocks. So for number 9, we'll say deposition of sedimentary rocks 10 through 18. Now, the whole reason we can see this massive sequence of rocks is you had uplift of the plateau and erosion by the Colorado River to expose all of these rock layers. So that should help you with both Outcrop D and Outcrop C. You should definitely check your answers, and good luck.